Okay, so why do some hydrogen-containing molecules act as acids and others don't? Why are some acids strong, others are weak? So we can look at H2S versus CH4. So this one's an acid, this one isn't. Why not? HCl is a strong acid, HF is a weak acid. Why? Well, this comes down to the strength of attachment of that hydrogen. So if we look at a binary acid, we've got H with some generic element Y, which is not the Y up there, but just some other element. In order for this to act as an acid, this molecule has to lose the hydrogen ion, right? And so the strength of this bond and the polarity of that bond affect how easily a hydrogen ion can be lost. So in order to be acidic, the bond has to be a polar bond with the hydrogen atom as the positive end of that polar bond. So the anion here, or the other element here, needs to be electronegative. Needs to be an electron hog, pulling the electrons away, because that makes the hydrogen already partially positive. And then when this gets lost, it's going to be lost as a hydrogen ion and not as a hydrogen atom. So if we see lithium with a hydrogen, you can make that compound, but this polarity is in the wrong direction. The hydrogen is actually more negative than the lithium. We can look at carbon-hydrogen bonds. Those are also not acidic because these are considered nonpolar bonds because the difference in electronegativity is 0.4, which is right on the edge at the upper limit of being a nonpolar bond. And then we have HF. This is acidic because fluorine is very electronegative and it's pulling the electron density away from hydrogen. So HF is definitely an acid, but why is it a weak acid? It has to do with the strength of the bond. The stronger the bond between the hydrogen and whatever it's bonded to, the weaker the acid. So hydrogen fluoride, fluorine is very electronegative and it's small. And so it's going to have a strong bond. The bond strength is going to decrease as we go down in the halogen column. So HF is a weak acid because it has a stronghold on the hydrogen. And as we go down, the bond becomes weaker because these elements, while they are electronegative and they do provide that polar bond that's needed, they are less electronegative and they are larger, and so the bond strength is less. We can look here, we actually have numbers for the bond energy. So 565, 431, 364. So that's why HF is a weak acid. We also see this occurring here, that we have decreasing bond strength going down this group, and we see increasing acidity. So H2O acts as an acid, but it's definitely a very weak acid, right? And H2S is stronger, H2SE is stronger, and H2TE is even stronger, so as it goes down. Any questions? Then we have oxyacids. In an oxyacid, the hydrogen is always bonded to an oxygen. It's never bonded to the other element, like the sulfur or the nitrogen. It's always bonded to the oxygen. And so we do have this polar bond here. But the nature of that element, whether it's, iodine or nitrogen or sulfur, is going to affect the strength of the hydrogen-oxygen bond. So if Y, that other element, is more electronegative, it's going to pull some of the electron density from oxygen, which is pulling electron density from hydrogen, and it's going to make this bond weaker. and that makes the acid stronger. So if we look here, we've got hypoiodous, hypobromous, and hypochlorous acids. Well, iodine has the lowest electronegativity, and it's going to be the weakest acid because its contribution to weakening this bond is less. Chlorine has a larger electronegativity, and so it's going to pull electron density away and weaken this bond more than the other halogens are. And so we see that its Ka is larger. Now, they're all still weak acids. Any questions? We also have an effect for oxyacids of the number of oxygen atoms that are bonded to that central atom. The more oxygen atoms you have, the stronger the acid. So perchloric acid is one of those strong acids, right? And here we've got chlorine with 4 oxygens bonded to it. All of these are contributing to pulling away electron density and making this bond especially weak. So this will readily lose a hydrogen ion. HClO3 is a weak acid. Its Ka is 1, so it's roughly 50% that it ionizes. Here we have 2 additional oxygens pulling electron density away. And with 2, I'm messing up here. So we've got 4 oxygens, 3 oxygens, 2 oxygens, and only 1 oxygen. And we see that as the number of oxygen decreases, so does the Ka, so does the strength of the acid. So this helps us to understand why perchloric acid is a strong acid, but chloric acid is not. It's this one. Any questions?